Hi everyone, welcome to my midterm presentation for CINF 202 Intro to Data and Databases class, where I will be covering the database design and implementation for the Spring Break SARAS case study. The agenda for this presentation includes an introduction to the project and the approach taken, a detailed look at the SBRU problem, the business process flowchart, and logical design using ERD, the physical implementation through SQL scripts, testing the database with sample queries, and concluding remarks. Each section is designed to walk through the complete life cycle of the database project, from conceptualization to execution and validation. Now let's move on the approach and tool selection. Before diving into the project itself, I wanted to explain my methodology. For many years, I worked with the classic LAMP stack using MySQL from the command line or through separate clients like PHP MyAdmin or MySQL Workbench. For this project, given that I work in SQL every day, I thought I would take it to the next level. My goal was to move away from that segmented workflow and integrate everything directly into VSCode, which is my primary code editor. After doing some Google searches, I found I could connect and manage and query my SQL server directly within VSCode, and I've included the instructions I wrote for myself in the appendix of my document. As you can see here are step-by-step instructions on how to install and get started with MySQL in VS Code. How to install it, how to install the extensions in VS Code, how to connect your MySQL server from VS Code, troubleshooting, and execution of the scripts that I prepared for this project. Similarly, I've used tools like Drawio for flowcharts in the past, like this one, but I wanted to find a more developer-focused code-based tools. My research led me to Mermaidchart for the business process flowchart and the Dbdiagram tool for the ERD. These tools allow for flowcharts and diagram to be version controlled and scripted, which fits this new integrated approach. This is the Mermaidchart tool that I was talking, and this is the Dbdiagram IO tool that I use for the ERD, which we'll go over in a while. Next step is the problem analysis, the SRBU problem description, business process diagram. So let's look at the problem we are solving. Spring Break SARAS, it's a travel agency stuck with an outdated paper-based system. This leads to major problems. It's inefficient, they can't track key data like student groups, and most importantly, there is no online portal for students to book trips. The solution is to build a modern database that can be integrated in a successive phase with a centralized web-based system, automating their core processes. Based on the case study, the first step was to map out the primary business process. The flow chart shows the end-to-end journey of selling a vacation package. It starts with the onboarding resort, moves through package creation, where room and flights blocks are combined, then covers the student booking process, and ends with the final payment and fulfillment. This process forms the foundation of our database design. Now let's go to analyze the logic model ERD. With the process understood, the next step is the design of the logic model, the entity relationship diagram. The schema has 8 core tables. Entities like students, resorts, flights, and room blocks hold our core data. These are combined into packages. The central transaction hub is the bookings table, which links a student and a package together. Finally, groups and payments tables handle those specific aspects of a booking. The relationships like one-to-many from students to bookings ensure data integrity. This model provides a comprehensive framework for managing all relevant data in the SBRU system. Let's go beyond the theory and deep dive into the physical implementation, schema DDL, populating the database, sample data DML. Now let's move from design to implementation of the DDL, data definition language script designed to create the physical database in MySQL. Each table in the ERD is translated into a create table statement. For example, if you look at the bookings table, you can see it has its own primary key, booking ID, and then several foreign keys, student ID, group ID, and package ID. These foreign keys are crucial as they enforce the relationships we defined in the ERD, ensuring that it can't be created a booking for a student or a package that doesn't exist. Here you can see the queries I created and stored in a SQL script file for control versioning to create the tables for our database. First, we start with creating the database itself, then we move on creating the tables, such as the students table with all the fields required as designed in our ERD, then the resorts table, next the flights table, the groups table. Here I encountered an issue. I wasn't aware that groups it's a reserved keyword in MySQL, so I had to use the backticks in order to create this table and its relative fields or entities. Then the room blocks table with all the fields needed. Then the packages table, the bookings table, and finally the payments table. A database isn't useful without data, so the next step was to populate it. To test the database, sample data is inserted using SQL data manipulation language DML scripts. The insertion order respects the foreign keys constraints, starting with the independent tables like students, resorts, and flights, followed by dependent tables such as groups, room blocks, and packages, and finally transactional tables like bookings and payments. This data simulates real-world scenarios that enables validation of the data model through a meaningful queries. Here is the file with the sample data queries stored for data versioning. Here is the sample data SQL file where we are going to insert data into our tables. First, we are going to insert data into the students table with the first name, last name, email, and date of birth values. Then we move on to the resorts table, adding the name, address, star rating, and insurance expiry date for our resorts. For the flights table, we are inserting the airline name, departure, airport, destination, airport, departure date and time, arrival date and time, total seats and available seats values in the table. Then, for the group table, we are inserting the group name, the creation date, group leader ID. Next, we go into the room blocks and we are going to insert the resort ID, room type, price, start date, end date, total rooms, available rooms, values for our entities. The packages table will get the package name, the price, the status, room block ID, and flight ID. The bookings table will get the student ID, group ID, package ID, booking date, and status values inserted with the sample data. And finally, the payments table will get the booking ID, the amount, the payment date, transaction status, and bank validation code values. Now let's go to test the model. We will start testing the model with some queries. To test the database, queries are used to simulate real-world use cases. Here in this file, I'm storing all the SQL queries I'm going to use for my project. The first query answers the question, what packages are currently for sale? And if we go to run it, as you can see from the results, it successfully joins the packages, room blocks, and resorts tables to show the package name, price, and destination. The second query is for a specific customer service scenario. Find all the bookings for a specific student. This query joins three tables to pull up the specific trip the student booked, demonstrating that the relationships between students and their reservations are working correctly. Additional queries further validate the model. Continuing with the testing, the query 3 demonstrates the group functionality by listing all the members of the Albany Spring Breakers group. This shows how the database links multiple students together through a single group ID. Finally, query 4 is a financial query that calculates the total amount paid for a specific booking. It uses a sum function and a group by clause, showing that the database can be used not just for retrieving the data, but for generating important financial analytics. All these queries run successfully, proving that the database model works for SBRU. But before we go any further, I want to show the data we inserted with the sample data provided earlier in each of our tables. First, for the bookings table, we have the data that we inserted earlier. For the flights table, this is the data. For the groups table, for the packages table, for the payments table, for the resorts table, for the room blocks table, and for the students table. In conclusion, the project successfully translates the business requirements of the SBRU case study into a functional relational database. The physical model implemented in MySQL efficiently addresses the core problems of the old paper-based system. The entire process from the design to testing was completed using a modern code-centric workflow in VSCode. The database now is ready to serve as the backend for the new web application to be implemented in a successive phase, and future enhancements could include social networking features and expanded reporting capabilities. This project lays a solid foundation for digital transformation at SBRU and will help SBRU grow and better serve its customers. Using a code-based solution for database and process design offers significant advantages over traditional visual tools. Because the design exists as a text file, it can be managed with version control systems like Git, providing complete history of every change and enabling seamless team collaboration. This approach reduces human error by defining the structure programmatically, ensuring the visual diagram is always an exact, consistent representation of the code, free from manual formatting mistakes. Furthermore, a code-based design enables powerful automation. The same script that generates an ERD can be used to automatically generate the corresponding SQL schema, guaranteeing that documentation and the physical database are always perfectly in sync. Thank you for your time and attention. This concludes my midterm presentation for CINF Intro to Data and Databases class. The project showcased a comprehensive approach to database design and implementation, integrating modern tools and methodologies to solve real-world problems. Questions and feedbacks are welcome.